So our first speaker, who will be opening this stage, returns to craft from having a long pause since 2015, but he compensated for that by leading 2 days of workshops. Thank you very much. Please welcome Simon Brown.
Awesome. Thank you very much for joining us. Good morning, Budapest. So yeah, this is my first time back in Budapest since about 2015, so it's certainly been a while. The topic of this talk is C4 models as code. To kind of set the scene here, architecture diagrams are historically very, very bad. These are sorts of representative diagrams I see all over my travels. UML fixes a bunch of these issues, but nobody wants to use UML these days, and I've literally heard every single possible excuse you can imagine for people not wanting to use UML. And most of these have been said to my face with a serious look on the other person's face. And there's, most of these are kind of made up. So enter the C4 model. The C4 model is something I created back in the kind of late 2000s as a way to put some structure behind architecture diagrams. And fundamentally, this is the underlying principle. If you don't want to use UML, and you don't want to use Archimate and SysML and those other formalized notations, if you do want to use just boxes and arrows, make sure you do so in a structured way, and ideally use a self-describing notation. That's essentially the essence, the fundamentals of the C4 model. These are the set of abstractions that sit behind C4. The top level one is called a software system. That's something that we as a team are building, delivering value and functionality to our users. Zoom into these things I'm calling software systems. I'm going to say they are made up of one or more containers, not Docker. It's a bit awkward. I got the name first. That's irrelevant. By container, I basically mean an application or a data store. Zoom into things called containers. I'm going to say they contain components. So components is a massively overloaded word, but I want to use the word component to mean this: grouping of related functionality, nice clean interface, running inside a container. So it's the container that's the deployment unit here. And if you zoom into components, they're basically made up of code: classes, interfaces, enums, functions, objects, etc. And C4 is actually named after the hierarchical set of diagrams. So there's a system context diagram, that's the first C, containers, components, and code. And really the concept here is diagrams as maps. So I live in Jersey in the Channel Islands, which is the little tiny island you see here. If you get this picture of Jersey, it might be too much detail for you because you don't know where Jersey is. So you zoom out, you pinch to zoom out, and you get some more context. On the flip side, you can zoom in and zoom in and zoom in, and eventually you'll drop into something like Street View. And Street View is a nice one-to-one mapping with the real world. And I want to do the same with architecture diagrams. I want different levels of architecture diagrams that allow me to tell different stories to different audiences. Some are high level, they're a nice starting point for many stories, and as we progressively zoom in, we progressively get more detailed, more technical. So down here, it's really architects and developers that are the primary audience for most of these pictures. The system context diagram. The top-level system context diagram in C4. In order to draw it, you need to ask and answer these basic questions. What's the scope of the system we're building? What features sit inside the system? What features sit outside the system, maybe in system integration points? Who is using the system we are building? Roles, actors, personas, real people. What types of things are they doing? And what are those system integration points? Answer those questions, and you can draft up a system context diagram. So the red box here is the system that this group, this team, were designing. They've correctly identified a couple of user types, and they've correctly identified a bunch of system integration points. There's some text, some colors. It all looks great. Now we zoom into that big red box in the middle, and we can drop down to level 2. This is a container diagram, and it's showing us applications and data stores. In order to draw a container diagram, it's a different set of questions. What are the major technology building blocks in terms of applications and data stores? What are the responsibilities of those building blocks? What technologies are we using to build them? And how do these building blocks communicate? For those who went to Sam's keynote, it's all about the arrows. Completely agree. Answer those questions, and you can draft up a container diagram. So what this group has now done is they've zoomed into that red box, and now they're showing the applications and the data stores inside that software system boundary. Tech choices, responsibilities, nice descriptions on the arrows, some technologies, protocols. It's all good stuff. And that's C4 in a nutshell. It's notation independent. This is one of the myths I see propagated a lot around C4. You know, C4 equals blue and gray boxes. That's not the case. You can use any colors, any shapes you want to, including hexagons. And you could also use UML if you want to. There's nothing preventing you using UML as your notation. So tooling, that's what we're here to talk about. If you go to c4model.com, there's a little tooling link. Click that, and you'll get this page. And what I've tried to do here is I've tried to assemble a list of all of the tooling that provides some specific degree of support for the C4 model. Some of these are diagramming tools, some of them are modeling tools. So most teams generally try to use, as a first attempt, general-purpose diagramming tools. Quick show of hands, who's using Visio, OmniGraphal, Diagrams.net, Draw.io as their architecture diagramming? Yeah, it's a good majority, right? And this is fairly typical. These tools are great. These tools are amazingly powerful and sophisticated, but I don't recommend them for doing architecture diagrams, especially if you're using the C4 model. Why not? Number one, these tools don't know what you're doing. So there are a small number of rules related to the C4 model and the diagram types. In a general-purpose diagramming tool like Visio, you can do anything you want, and you can break that small set of rules. So a system context diagram really only should include people and software systems. But it's very easy to draw a context diagram and start adding other things like components, which is kind of not in the spirit of C4. So the tools can't help. Number two, there's no consistency. If you want to draw a context diagram and then a separate container diagram, in a tool like Visio, you now have to open 2 tabs. And you have to start copy and pasting boxes and arrows between those 2 tabs. If you rename one of the boxes, you need to make sure you rename it in both places. Otherwise, you get this situation. Business user on one diagram, report viewer on the other. There's no consistency. The tool can't help. If you try and export these things to text-based formats to stick them in Git, that's often what you get. Which is kind of annoying, because if you just want to rename a box on a diagram, you often get something that looks exactly the same, or maybe very, very different, like the whole file is diff. So these files are often hard to diff. These tools don't provide automated interfaces and APIs either, in many cases. So it's very hard to integrate tools like Visio into your CI/CD build pipeline. So maybe you want to scan your AWS environment and build a diagram. That's kind of hard to do with tools like Visio. And also a pain in the ass. They're very time consuming. You always get the situation where, this text almost fits. Do you line break it, and then you have to realign all the text? And this line's not straight, it's 1 pixel out. Yeah, you've all done this as well. You kind of move a box and it's 1 pixel the other way and you just can't fix it. So back in 2020, Diagrams as Code blipped on the ThoughtWorks Tech Radar. Diagrams as Code is basically a way that instead of using a UI to drag and drop boxes, we're writing a short piece of text, and we're using tooling to draw diagrams, generate diagrams for us. Diagrams as Code is therefore an inherently text-based approach. As developers, we love text. We have tons of tooling to support text. We can do global search or replace. We can version control text. We can diff text. And many of these tools have great automation opportunities through APIs and CLIs. PlantUML and Mermaid are probably the most popular tools in this space. PlantUML does not support C4 out of the box, but somebody built a bunch of macros for PlantUML called C4 PlantUML, and it allows you to use a kind of domain-specific language to describe diagrams. So here we're defining a person, a software system, and a relationship, and this text draws this little picture. The problem with these tools is they're inherently still diagramming tools. If you want 2 diagrams, you need 2 text files. If you rename an element in one text file, you have to rename it in the other text file. Yes, you can do includes. Yes, you can use global search or replace, but fundamentally, 2 diagrams, 2 text files. I want to shift the narrative away from diagramming and back to modeling. Now, modeling is something we used to do back in the late 1990s, early 2000s, spot the old person in the room, and many people have been burnt by things like rational rows in the past. The concept of a model is very simple. A model is a single definition of elements and relationships, and you reuse those elements and relationships across all of your diagrams. If you want to rename an element, you rename it once in your central model, your central dictionary, and all of your diagrams magically change as well. That's the power of having a model. So during the pandemic, I could not do any traveling. I was stuck on my little island of Jersey, and I built a whole bunch of open source tooling. And the primary tooling we're going to show you today is called the Structurizr DSL. So this is open source, it's text-based, and it's really specifically built to support creating diagrams based upon the C4 model. And I'm calling this Diagrams as Code 2 to differentiate it. What you do here is you craft up a single text file, and from that single text file, you can generate multiple diagrams off a single set of model-based elements. So it's a lightweight text-based modeling approach, essentially. People say, well, what's the benefit of doing this? Things like C4 PlantUML are very easy to get started with, but as your models start to get bigger, or you want to start using C4 PlantUML across multiple teams in your organization, you tend to get to a situation where you start lacking consistency. You want to share things between diagrams, which is just a bit more complicated, and the whole thing falls apart very, very quickly. So for me, this is it's a solution to longer-lived documentation at scale. And there are organizations using my tooling here at enterprise-wide scales. So really, this is models as code, or more specifically, C4 models as code. A new thing for this year is all of the stuff I'm going to show you is now completely all open source. So I open sourced a big chunk of this code base, pretty much all of it at the start of the year. So all of the DSL I'm going to show you is open source. The underlying Java library, the CLI is all open source. There's something called Structurizr Lite I'll show you. There's an on-premises installation. There's a bunch of export formats. All of that stuff is open source. You can find it very easy on GitHub. So let's drop into doing a demo. So here we have my desktop, which is empty. And that's a win in itself, isn't it? So what we're going to do, so I have some tool called Structurizr Lite. Structurizr Lite, in its basic form, is a pre-built Docker image that you can pull down from Docker Hub, start it up, and it basically allows you to view diagrams and documentation. So what I'm going to do is I'm going to start up Structurizr Lite against a folder on my desktop that doesn't yet exist. We pause, we pray, there we go. So that starts up now. What you'll see now is this folder's been created, and inside here is a workspace.dsl file. And if I open this up, this is the Structurizr DSL. So what we're doing in the DSL is we're defining a workspace. A workspace is really a wrapper for two things. Number one, a model, and number two, a set of views. So the model is where we define our people and our software systems and our containers and our components and more things. So here we are defining a person with the name user. We're assigning that to a variable called user. We're defining a software system with the name software system, assigning that to a variable called software system. We can change these later, don't worry. And we're defining a relationship between the user and the software system with a description of users. So that's my elements and relationships. That's my model. Then what we are doing is we are defining a C4 system context view. The target and the scope is that software system we defined at the top. And ignore this, it's just a diagram identifier. We're saying include star. Include star does some magic here. And what it does is it includes the software system, and it also finds anything that's linked directly to that software system, and it includes it in your diagram. And we are saying apply automatic layout. So that's the DSL. Nice and simple, nice and straightforward. To get some diagrams, we now need to go to our web browser. This has done a port map to localhost 8080, so we're going to go there. And this is Structurizr Lite. So this is a browser-based, JavaScript-based, SVG-based diagram renderer that renders us this wonderful looking diagram with 2 square boxes in gray. But we can fix that later. Now, the first thing I want to show you is this is automatic layout. I don't like automatic layout. It always puts boxes in the wrong place. It never quite works once you get past like 8 boxes, 10 boxes. So how do we fix that problem? What I'm going to do here is turn off automatic layout by removing that line. Save this, go back here, refresh. Now we can move things around and we have more toolbar buttons and we can change the page size, etc. We can save it. Now what I can do is I can go back here and I can change the name of this thing to be, say, business user. Save it, go back, refresh, and it retains the layout. So I guess there are 2 questions here. Number 1, where is the layout being stored? Because it's not in here. And the answer is there's a JSON file here now. And this JSON document is essentially, I don't want to do that. This JSON document is essentially the canonical data structure used by all the Structurizr tooling. And it's really just a version of the same information. So here is our user, the business user. We defined in the DSL and a bunch of properties. Here's our software system. And here is the view, and you can see all of the XY coordinates. So what you do now is you take these 2 files, take this whole folder, check it into source code control, along with the script to start up Structurizr Lite, and now anybody can get that same set of diagrams. So that's kind of the first thing I wanted to show you there. So let's imagine that. Let's close this one down. Let's imagine that we've drawn our context diagram and we're happy with it. And we want to draw a container diagram for that software system. With PlantUML, you now spin up a new file. With this one, you just add more things to the same file. So now what we can do here is we can open up a set of curly braces, and we can start typing some things. So let's have a web app. This is going to be a C4 container called web app. And let's have a database, and that's also going to be a C4 container. And we're going to call it database. And we're going to say that the user has a link to the web app, uses, and the web app has a link to the database, and we'll say reads from and writes to. So if I save this and refresh, what do you think is going to happen? The answer is absolutely nothing. So we've added more things to our model, but we don't have a view that allows us to see those things. So how do we create a view? Well, we need a container diagram. How do we create a container diagram? What we can do is we can go down here, copy this, paste it. We're going to change this to container. So we're going to create a container diagram for the software system. We need to change this diagram key. Include star now does something different. It says include all of the containers inside that software system and also include other things that link to it. So if I save this, go back here, now we've got our context diagram, and you'll see this little zoom in symbol here. So now we can double click, and we get to our container diagram. And we can apply automatic layout if we want to. There we go. Let's do automatic layout left, right. So now we have consistency across both our diagrams. It's the same. I can rename that business user, and it will change in both places. Something you may have noticed is that I've got some duplication here. I'm saying that the user has a link to the software system, and the user also has a link to the web application which sits inside the software system. And that's what's giving me those 2 arrows on the 2 separate diagrams. But that, to me, feels like it's a breach of dry, don't repeat yourself. So how do we fix this? Well, we need to delete one of the lines. Now, we have to choose the correct line to delete, but I'm going to delete this one, go back here, I'm going to go back to my container diagram, hit refresh. So this arrow here is the arrow we are defining in the text file, the one between the business user and the web application. If I go back to my context diagram, it still exists. So this is a feature of this whole framework called implied relationships. Because there's a link between the user and the web application, there is an implied and implicit relationship between the user and the higher level of abstraction. And that's a feature you can customize and turn on and off and all that good stuff. So let's fix gray boxes. Who likes gray boxes? Answer: no one. So let's figure out how to do that. What we can do here is we can turn on tooltips in the UI. And if we start hovering over things, we'll get a little tooltip. Inside this tooltip, you'll see two little boxes. One says element, one says person. These are text-based tags associated with that business user element. So there's an element tag and a person tag. The software system has an element tag and a software system tag, and the relationship has a relationship tag. So for any front-end developers here, or if you're familiar with HTML, this is basically the same as CSS classes that you apply to HTML elements. So what we can do is we can now craft up a bunch of element styles for those specific tags. So let's create a set of styles. We're going to create an element tag, an element style for the element tag. So this is going to apply to all elements. Let's go back. Oh, I can't type today. More caffeine needed. Let's go background orange since we're at craft, and we'll go foreground color white. So if I save that, go back here, now all of the elements have orange background, white color. So this is exactly like CSS. If we want to change the color of a container to be something else, let's do element style for a container. We'll do background. Is orange red a thing? Let's try it. There we go. So now we have a darker orange for those containers. If we want to change the shape of the person, we can do that by creating an element style for the person tag, and we can say shape person. If Sam Newman was here, he probably wouldn't use a hexagon, so let's make some of these containers hexagons. Do you know how long it took me to implement hexagons in this tooling? A long time. A really, really long time, because you have to work out SVG angles and things. Don't recommend it, but we do hexagons as well. So we've got the database as hexagon. That's awkward. Tooltips. So the database element has an element tag and a container tag. I want to create a new style, but I don't want to change all the containers. So what I need to do is I need to add a specific tag to that database element, and then I can style it. So how do I do that? I go back up here. I find the database. I say tags database. Seems reasonable. Now I can save, go back, refresh, add tooltips. Now it has a database tag. And we can do the same thing as before. We can say create an element style for the database tag. And you know what the shape's going to be? It's not database, it's cylinder. There we go. One of the big things you'll see in some of my talks about C4 is that you should create a self-describing notation and ideally use a diagram key for any notation, shapes, colors that you use. This tooling does that for you. So based upon the set of tags and styles, it can work out all the combinations, and it will generate you a diagram key auto-magically, which is quite nice. What else can we do? We've got exports to PNG here. So if you want to download high-res versions for sticking in Confluence or Markdown files or something, that's absolutely fine. Similarly, there's a SVG export that you can do. And there's a bunch of other things I will talk about later. So that's kind of fundamentally the Structurizr DSL and the Structurizr Lite tooling. Now, the nice thing about the Structurizr DSL is that it's actually rendering tool independent. So let me show you that in action. I'm going to go to my cloud service, which is at structurizr.com/DSL. There's a demo page. I'm going to take this DSL that we've created. I'm going to copy it into here and render it. So if you want to go try this tooling out, you can go to structurizr.com/DSL. And this is going to give us the same diagrams we saw as before. Except, of course, I didn't. Let's put automatic layout on. Oops. And then we can see what's going on. There we go. So there's my container diagram. I've built a bunch of exports to other formats, including things like PlantUML and Mermaid. And again, this is all open source. It's all on GitHub. So this is my Structurizr Lite, my Structurizr web-based JavaScript SVG renderer. You can also do an export to PlantUML, so you get a bunch of PlantUML code here, and we can render it PlantUML, and there we have a different version of the same diagram with the PlantUML tooling, and that will generate you a diagram key as well. It's quite nice. There is an export to C4 PlantUML. So C4 PlantUML has a default kind of blue and gray boxes and arrows notation, but you can change that by going down here and doing properties, C4 PlantUML.tags true, click render, and now we'll get a different version of that same diagram. So if you like using C4 PlantUML, you can have my tooling automatically generate you a whole bunch of C4 PlantUML diagrams. And I should add that this will generate you all of them. So there's the C4 PlantUML version of the same context diagram. There's an export for Mermaid, which does the same thing using the Mermaid's tooling. All these different diagrams as code tools will look very different because they use different algorithms. There's an export for dot and graphics and web sequence diagrams if you're using dynamic diagrams. So that's kind of quite nice. Now we have a rendering tool independent way to create a bunch of architecture diagrams, and every rendering tool has its own set of trade-offs, advantages, disadvantages, and so on. So I'm going to stop my Structurizr Lite thing here, and I'm going to boot up Structurizr Lite against another example. And for those of you who are familiar with C4, this is the set of internet banking system example diagrams that I show in my workshops, training courses, talks, and on the c4model.com website. So we'll boot these diagrams up in Structurizr Lite. So here we have the system landscape diagram, double-click to the context, double-click to the containers, double-click to components. So that's my set of diagrams here. There are also support for dynamic diagrams, which are all animatable, and deployment diagrams, which are also animatable. So this tooling supports the full set of C4 diagrams. So this is my Structurizr rendered version of these big bank diagrams. I love hearing the trains go past. It's very weird, isn't it? Let me start up another tool now. So there's another tool, which is also open source. It's called the Structurizr Site Generator. And it's the same thing. It's a Docker image you can pull down and then start up. I'm going to point Structurizr Site Generator to that exact same folder. It's going to boot some stuff up. I'm going to open up another tab. So this is Structurizr Site Generator now running. And it's just a different way to look at essentially the same data. So here we have a list of all of the software systems defined in that workspace. We can click the internet banking system. It gives us some documentation. If more documentation was associated with that element, we could see it here. And now we can start drilling through the different diagrams. So here is a PlantUML version of the rendered diagram, rendered via Structurizr Site Generator. And this is hyperlinkable. So now we can start clicking around, and we can start to drill through the diagrams, or we can do the same up here as well. So that's another nice tool. It gives you a different way to kind of look at these various diagrams. Let me try one more tool. This is a little bit risky because it doesn't always work for reasons I don't understand, but it's called C4Viz. It's also open source, also on GitHub. This one takes a little bit of time to start up, which always makes me nervous, because it sometimes gets stuck here. I think we're good. Let's see what happens. Oh, no, I didn't want that one. C4Viz. There we go. So this is this is kind of a clone of Structurizr Lite, but it's not using a browser-based rendering engine. It's using C4 PlantUML. And same thing, the author has added hyperlinks to all of these diagrams, so you can click through and look at the various levels of detail, which I think is also really nice. Let me shut this one down. Let me go back to Structurizr Lite. Just do this. It's going to be quicker. I'm going to show you another example. This is it's a workspace that defines my fictional financial risk system, if anyone has seen it in my talks or been in my workshops. And the reason I want to bring this example up is that Structurizr Lite also allows you to embed these diagrams in Markdown and ASCII documentation. So this is the workspace as it boots up in Structurizr Lite. And all of this text here is just basically plain Markdown. So I can go and show you the source of this. This is the financial risk system. There's a docs folder, there's a context file, So this is just plain Markdown, with the exception of this little image tag, which is a little bit special. It's saying embed context. And this is saying embed the context view defined in this workspace. And this basically gives rise to and renders as that. So this is a nice way to pull all of your diagrams as code and all of your Markdown and ASCII documentation together in one tool that you can use to visualize all of this stuff. And this is the live diagram, so I can go down here and I can say, give me the diagram key. So this is like a live iframe embed inside Markdown, and you can do the same with ASCII doc. It's all text searchable, et cetera, et cetera. Anybody using architecture decision records? If you're not, you should. Highly recommend it. Tons of resources out there. If you have a folder full of architecture decision records, this tooling, you can point it to the folder, and it will render your ADRs in the browser for you. So you get a nice summary here on the home page, and then you can start clicking around, looking at ADRs. If ADRs are linked, you'll see those things. There's a little graph here, which is kind of quite nice. You can see that this one supersedes this one here. Again, it's another nice way to visualize ADRs. So that's the basics of the Structurizr Lite tooling. I'm going to shut this Docker container down. I'm going to reboot another one. See how many Docker containers we can get going in this demo. One of the big questions I get a lot of time is, how do we use C4 to describe bigger, more complicated architectures, or things like distributed microservice-based architectures? Because again, there's this myth I've seen pop up a number of times that says C4 is not good for distributed architectures. And that's not the case. So imagine we have a microservice-based architecture. And imagine this particular architecture is made up of 8 services. Now, one of the things I like to do here is I like to be a little bit specific about what we mean by microservice. In terms of C4, I generally consider to be a microservice as being made up of typically 2 containers. There's an API thing, so this might be like a Spring Boot app exposing a JSON API, and typically most services have some sort of a data store. So from a C4 perspective, most microservices tend to be 2 C4 containers. So what I've got here in this diagram is pairs of containers with a grouping to say these 2 containers make up a service. So with that explanation out of the way, we have an architecture here. It's made up of 8 services. And I've given every service a different color, and of course I'm using hexagons. Why not? This diagram is okay. It kind of works with automatic layout. Every time you add more services, you're adding more boxes, more arrows. At some point, this diagram will get a little bit crazy and a little bit cluttered. So the question becomes, well, what do we do next? This diagram is essentially showing you one diagram with all 8 services. What we can do instead is perhaps draw 8 diagrams, each focusing on one single service. And that's what I've done here. So here is the service 1 diagram. So we're focusing on service 1. We're showing things coming into service 1, and we're showing things coming out of service 1. So the afferent and the efferent couplings, the inbound and the outbound dependencies. Then I have created a service 2 version, a service 3 version, and you get the idea. How do you do this with a tool like Visio? You open up a new tab, you find all the things you want to copy-paste, you copy-paste them manically across all the different tabs, try and keep everything up to date. It's a horrendous nightmare. What you can do with this tooling is something quite clever. So here is the workspace that is used to define this. This is all on open source, on GitHub. It's open source. There's an examples repo. You can grab this from if you want to play with it. Here is my definition of a service. So a service is a grouping of an API container and a database container. That's the grouping there. And I've just done that multiple times. Go away. 8 services. Scroll down. Here are all the links between the services. This is the all services container diagram. It's basically saying, create me a container diagram for that software system, include all the services, and apply automatic layout. And these are the individual service diagrams. So here we're saying, create a container diagram for the software system, include service 1, things coming into service 1, and things coming out of service 1, so the afferent and the efferent couplings. And this is how nice and easy it is to kind of slice and dice your larger models. So this works for things like large serverless Lambda function as a service type architectures, large microservice architectures, or big portfolios of systems, systems of systems. Also good for things like lots of components sitting in a monolithic application. So there's a whole expression language built into the Structurizr DSL that allows you to slice and dice the model, and you can get quite specific about things you add and exclude from your diagrams, which I think is quite neat. So that's option 2. Option 1 is show everything. Option 2 is show lots of smaller diagrams. Let me go back here to this nice all services diagram. The trade-off you make when you have those individual service-based, service-focused diagrams is you lose all the context. All of the other services kind of disappear from the diagram, and sometimes you do want to see everything. So how could you see everything without creating a very cluttered diagram? The answer is you go to Structurizr Lite and you click this button, and you get that. And this is very relaxing to play with. It's a JavaScript D3 force-directed graph, and it's showing you the same information as I showed you before on the all containers version, but it's using a much more condensed, concise visualization engine. Here it has tooltips, so you can embed more information in the elements, and those show up on tooltips. You can click and show nearest neighbors. So now you can start to look for dependencies and impact of change, and there's a quick find feature if you really have tons and tons of stuff. So that's another alternative way to explore and visualize a larger set of architecture elements. And of course, this is interactive. This is not going to work as a PNG file stuck in Confluence, I'm afraid. So that's another option for you. I do have some CLI tooling around all this. So let me shut down Structurizr Lite. If I run my CLI tooling against that workspace, so I'm going to use the CLI to export. The workspace is going to be users, Simon, documents, Structurizr services, workspace.dsl, and I'm going to say format elo graph. So this is another tool. It's nothing to do with me, but I thought it was quite nice that I created an exporter for it. What this has done is it's exported the elements and relationships in that services workspace into a, quite frankly, rather horrible-looking YAML document, but don't hold that against it. I'm going to copy this into my clipboard. I'm going to go back to Chrome, open up yet another tab, and go to ilograph or elograph.com. I'm going to click New Diagram. I'm going to take that out, put mine in, click that, and here we have another option for showing larger amounts of data. So this tool is a really nice kind of interactive, explorable UI that's great for showing large data sets of hierarchical data, essentially. And, I mean, it's YAML. I don't recommend you handcraft YAML. That's why I built the exporter. But the nice thing about this is it's interactive. So again, you can start clicking around, and more or less detail starts to show up depending on what you're clicking on. So again, this is another really nice tool. So you can go from the DSL to a bunch of different tools, and those very different tools can do different things. They can show you different things with your data, which is quite nice. I'm going to show you a couple more things before we finish. Something you can do is, so I have IntelliJ open here, and I have a bog standard Java command line app, and I have a Gradle build file here, and in my Gradle build file, I have added a dependency on the Structurizr DSL parser. So again, that's all open source. It's all hosted on Maven Central. And what I can do is I can write a little Java program that says, create a new DSL parser, parse the DSL file. In this case, it's going to be that craft example that I showed you before with the orange boxes. Load the workspace into memory. Then go and find the container that we defined as having a key of web app, and then add a logging component to it. So if I run this, there we go. So these are now all the elements that are in that workspace. So what I've done is I've loaded the DSL, and now I've manipulated the workspace via Java code. And you might be thinking, well, that's not a particularly impressive demo, and you'd be right. But what you can use this to do is you can craft up like a high-level version of your architecture with the DSL, and then you can load it into a Java program, and now you can go and scrape your Terraform config files or your AWS environment, or you can do identification of components using Java's reflection mechanism. You can pull that into the workspace. You can then dump this out as a JSON file, and now you can plug it into all of the other tooling I've shown you. So there's really a nice way you can start to use the DSL along with code in a kind of nice hybrid fashion. There are ports of the underlying Java library here, the Structurizr for Java library in other languages. There's also one for .NET. It's not quite as well as supported, but we can do the same thing. There's no DSL parser in the .NET version, but we can load up the JSON document and deserialize it into a workspace, and then we can, in this case, just dump out all of the elements. And again, the same thing will work. So here we can see, here is all the elements we defined in that DSL file. So now we have some degree of interop between the DSL and other languages. As I said, that JSON document is the canonical data structure, canonical data structure used by the Structurizr tooling, and it's just a JSON document, and it's defined as an open API 3 Swagger type definition. The definition is also available on GitHub. So that's pretty much all I wanted to show you. There's a whole bunch of other stuff that the DSL can do, which I've not shown. Things like workspace extension. So workspace extension allows you to define a workspace and then have teams extend it. And what enterprises generally use this for is they define a single workspace with all of their software systems and people, and then they allow teams to extend that single workspace and add information about containers and components. So in other words, add information about the implementation details of all of those software systems. If you're using something like Spotify's Backstage or another service catalog, again, you can start integrating this tooling with those other tools to generate you things like system landscape diagrams. There's a way in the DSL to do include, so you can take out snippets of reusable code and include it into your workspaces. Because all of this tooling is built on Java, there's the ability to add scripts, so you can do Groovy, Kotlin, or JRuby scripts embedded into your DSL files. And for those of you who are Java developers, you can also write plugins that allow you to create more reusable and potentially much more complicated plugins for the DSL parser. So that's pretty much it. If you kind of thought this is useful and you want to get started, go to structurizr.com/DSL. That's that demo page where you get a text box on the left, and you can try out all the different diagrams on the right. All of the other kind of rendering tool agnostic approach I've shown you are also listed here. And don't forget, just to reiterate, all of this stuff I've shown you is completely free, completely open source. So thank you very much. Happy diagramming.